Hi there. Today we will finish off our calculations for case B. So we stop somewhere here, right? Now, okay. Remember case B, this value here, case B, will is for what? Is for sparingly soluble substances and it's ionic substances. What is the ionic product? For example, here the question is solid product case B of magnesium hydroxide has a numerical value of 2 × 10⁻⁹. It's very small, okay? So it talks about sparingly soluble substances. Now, I'll write an expression for KSP for magnesium hydroxide staying units, okay? Very simple. Remember, always start with the equation, right? This is, of course, solid. You want to put solid here, this is A equals, and this is A equals, okay? So a small amount will dissolve, and always start with let solubility of X mole specific. Always remember, this is a key thing for calculations, but of course, from here, you just put the species, okay? So it's the ionic product. These two are called ionic product. Ionic product, okay? The word is called ionic product, right? You talk about the species. The species is power 1 because it's stoichiometric, is 1 mole here. It's power 2 because why stoichiometrically is 2 moles here, that's all, okay? So give you the value of KSP, this one here, and calculate the concentration of this one here. Okay, MgOH2, the saturated solution. Means solution means what? Means solubility. Okay? The solubility of a substance is the amount in grams or moles of a substance dissolved in 1 dm cube or 100 cm cube to form a saturated solution at a given temperature. Saturated solution. So we use the solubility. Okay, now, this is the old term of this. Okay, X moles here. So now this is the actual amount 2x. Okay, so you put x here, you put 2x, and you square it. So you have 4x cubed, right? So you can solve the problem and this answer here. Okay, 1.71. 1.71, you can check the answer here later, okay? So it's all mathematics. So I explain whether magnesium hydroxide will be more or less soluble in 0.1 mole of magnesium sulfate. Of course, magnesium sulfate is soluble. Why? Because poor big cow sucks in it. Poor big cow sucks with sulfate. Okay? All these are insoluble. The rest of them are soluble. So MgSO is soluble. Okay? So this is soluble here. Of course, you will dissolve to give you Mg2 plus and SO2 minus. So you put magnesium sulfate, magnesium hydroxide here. Okay, so this is the equation. Dissolve means go forward. So in water, of course, there's nothing to common ion here, but in here, in your magnesium sulfate here, the common ion is magnesium. Okay, so the magnesium coming from here, from the MgSO4 here, will cause it to go backwards. So it's all right. Okay, so it's soluble. So the MgSO4 plus increases, so common ion effect shifts the things backwards. So it's less soluble. So less soluble, and the reason why, okay, see here, okay, less soluble because of common ion effect. What about okay, less soluble, okay, because of the two things there, common ion effect, and what's right this equation like that. This going forward is soluble, going backwards is less soluble. Okay, all right. Okay, now here, yeah. Okay, so here is a bit different. It's quite a good question here. Old question actually. Lead chloride is slightly soluble in water. Yes, a little bit soluble. You heat it more soluble. See, it's -5 only compared to -11 or 12 or 20. Okay, so it dissolves this way, right? This way here. Okay, so P2 plus 2Cl minus. So right expression for blah blah blah. It's quite simple here. Species and the square according to the mole ratio. Okay, so units here, right? Now there's a calculate PB concentration to plus in the solution of the PB2 plus. Okay, that means in water. Okay, this one here is A equals. So this is the first one here. Okay, I draw 2 because this is the second part. Okay, so in water you put inside here. All right. So again you put let the solubility. Remember I told you always use this thing here. Start with this one. Don't be stupid. Okay, don't be like a hard-headed cow and don't do this. Always start with this because this is very important. X because it's 2x and so forth 0. So x is x. His x is 2x. So you put inside here, you must put the 2x inside here for Cl minus 1. Okay, so it's 4x cubed equals to the KSP value. So again, you solve mathematically x equal to this. So this x plus in water is 1.71. Okay, it's not we done before then -2. Okay, so see here in water is on here. Right? See 1.71 -2. Okay, now then the second question here is when an excess of lead chloride solid, okay, here also solid. But the first one here is you put in water, okay, right? The first one you put in water here. Second part is stir in a sodium chloride solution, Okay, I put red color so to differentiate what I've done here. Okay, right here. Okay, is 0.5 mole. That means this one here dissolve. It means if 0.5 moles here is 0.5, 0.1, it's dissolved completely. So Cl- is already there, right? So of course PbCl2 will find hard to dissolve because of common ions here. Okay, so here now mind. Okay, so now let's begin an excess of PbCl2, so it's stirred with 0.5 moles of per dm cube of sodium chloride until equilibrium has been reached. Okay, that means it will dissolve. But how much dissolve? It will be different from in pure water, isn't it? Okay, so the excess of PbCl2 is filtered off, assuming Cl- remains the same, Okay, I explain what I mean. Okay, throughout, cover the Pp2 plus in the green solution. Now, remember? Okay, now this is PbCl2. You dissolve here. Okay, right? Now you can do this before and after. Actually, I used to use before and after one. Okay, okay. Before you put inside there and after you put inside there. Okay, this is the simplest way. Before you put inside there, the concentration of Cl- is 0.5 moles per dm cube. Okay, the Pb2 plus is what? Is 0. Okay, it's equal to 0. 0. Nothing one. After you put inside there, the Cl-, okay, total, okay, the Pb2 plus. I don't care about the Na plus because it's nothing to do with anything calculation. Okay, it's X moles per dm cube. So this will be 0.5 plus X naught. Okay, X naught. Yeah, but they tell you that, well, assuming Cl- remains here, that means the X is very small. That means this one is too small to affect the 0.5. So it gets to 0.5. See that? Okay, so use that. And this. So, okay. So then, of course, you put down here. All right. So remember, KSP is equals to, this is it, right? Okay, it's equal to this value here, right? 2.0.5. You can see here, on top of here. Okay, KSP is always the same at a given temperature, right? So it's here. So you put X inside here, this amount dissolved, and this is the 0.5 because the X from your PbCl2 is too small to consider. Okay, so goes here. So again, it's all mathematics now. Okay, X equals to this, and this is the value here. 8.0 to the power minus 5, and compared to here is minus 2. See that? Minus 2. That means the solubility has decreased because of common ion effect. Okay, suggest and explain the difference in this value with the, okay, of course. Why? Because when you dissolve, when you put PbCl2 into water, there's no Cl- there. But put PbCl2 into NaCl, the NaCl there will, the increase in concentration of the NaCl will force it to go backwards now. Okay, that means it become less soluble. So remember, when you put the PbCl2 into this, the concentration of Cl- has increased. Common ion effect, shift equilibrium backwards. Now always write the equation here. Shift backwards, so we cannot blame me or whatever. Because sometimes we put this on here. Okay, so sometimes you don't know what you're talking about. See? So you put the equation here, then you explain according to this equation here. You cannot put it wrong. Yeah. So this one you shift backwards. So because this becomes less soluble. See now. So you can see here. Okay, common ion effect increase in Cl- force the equilibrium to shift left. So less soluble. Okay, so this is the equation, shift left according to this equation here. See here, right? Difference in value. Of course, it's decreased. See, okay. So when you explain, you always write the equation of which equation you're talking about. Shift right, left, which one? Going forward is on here or going backwards. Okay. All right. Next one here. All very simple one. Silver bromide is expanding soluble water. Again, this equation here. Okay, right now this is going forward. Okay, this going forward. This is soluble. Okay, we always use KFC to form ions one, for ion product. Okay, so covering the Ag plus and so forth. Again, remember. All right, the equation here. This is the KSP expression. Covering Ag plus, you put the solubility be X naught. Okay, if X here, and X here. Okay, so X squared equals to this value here. Again, it's a mathematical. Okay. Now here again, instead I explain whether AgBr, which is a solid, is less or more soluble in 0.1 mole of KBr. Okay, now this is water, and this is your KBr. Of course, KBr will be totally dissolved because all PAS solubles here. So there's already a concentration of Br minus here, right? Right. So of course, in this case, you make sure you refer this one here, this equation here. So there's when you put this here, there's already a Br minus here. That means Br minus will increase. We shift it backwards now, common ion effect, isn't it? So make it less soluble, isn't it? So I put here increase the concentration of Br minus common effect. Shifts the equilibrium to the left, okay? According to this equation to the left here. So less soluble. Now let's see what magnesium is. Okay, if less soluble, you must put less soluble here. Why due to common effect, shift the thing to the left, okay? Which means to refer to what? This equation. Shift to the left. Always write again the equation, okay? Okay, right here the equation again. Okay, if you have a problem, right here again. Solve it. Okay, so that examiner cannot but give it a mark because you're referring to the right equation here. Sometimes they talk about different equations, eh? Okay, all right, next one here. Calcium hydroxide, less soluble in water, soluble in water, and so forth. Expression here, quite simple, okay? Remember square here, units here. Okay, now this titration, 25 cc of a saturated solution of calcium hydroxide requires 21.005 moles of HCl, okay? HCl, acid, and alkali is not neutralization, okay? Titration. Current OH minus and the Cl minus Ca2 plus in the saturated solution, and hence, okay, very simple. It's very simple. So there are two ways to do this. You can use this equation, or you can use the ionic equation, up to you. The marking scheme use some, I like to use one here. This is easier, okay? Calcium hydroxide, 2 moles of HCl, right? So here, so again, put the blue color line so you can easily distinguish here. All right, so here is your V1, so forth, M1. So number of moles of HCl is this one here, okay? So number of moles of calcium hydroxide will be of half, because this is 1 or 2, 1 is to 2, okay? So number of moles of calcium hydroxide is half of this one here, right? So remember, 1 mole of calcium hydroxide here, give 2 moles of OH minus, okay? So 1 is to 1 is to 2, so OH minus is 2 times this one, so times 2. And this dissolves in how much? 25 cc only, okay? See, 25 cc. Okay, I want to find mole per dm cube now. So to find mole per dm cube, remember, change the mole per dm cube by titration, okay? Over this one over 25 cc. Okay, so this is mole per dm cube. Okay, so of course, in this case here, this is the OH minus here in this solution of saturated solution here. So if it's 2, here will be 1 is not, right? So half of this. So it's 4.2, 10 power minus 2, here's 2.1. So this one you put inside here. Remember, this one here, the concentration here, you must always remember this thing here, this gundu here is moles per dm cube. Okay. This one here is moles per dm cube. Okay. So it's 3.7 10 power minus 5 mole cube minus 9. You can see 3.75, 3.7. Okay. 3.7 here. 3.7, 3.75, 3.7. Okay. Right. Correct. Is it? So the marking scheme, everyone got, okay, in 25 CO, and marking scheme is okay. Right. So see how it goes. Again, here, same old question of common ion effect. They always ask you with common ion effect. Okay. So how would solubility of calcium oxide be in NaOH? Of course, like NaOH and water, compare this to. Here, of course, give you the OH minus. So when you go down here, there's common ion, is it? Okay, we'll shift one backwards. Okay. So how would solubility happen? Must say solubility will decrease. Why? Because the OH minus here, common ion effect, shift it backwards again to the left. Okay, see. Less soluble, 1 mark, less in black. Okay, because the common ion effect, OH minus 1 high will shift it backwards. They didn't say what, okay, left hand side. Left hand side. Okay, 1 mark only. Okay, next one here is done already. Okay, this is a simple one. This we did before this one here, but here they ask you, they put inside here just to test you. Okay. Expression for solubility about PbCl2 quite simple. Remember, write the equation first. Remember the ions are on the right hand side here. Okay, right. Calculate the KSP value. Very simple because you know that here the solubility is given here. Okay, right. See now the solubility is given here. So from the top part here, so of the whole thing is of this X now. Okay, so PB is X here, right? It's 2 times now. Okay, square. So don't make a mistake here. As I say, let solubility be X now, easier. Okay, so you won't make a mistake. So x here, x, 2x here. So this is given as 3.5 to the power of minus 2. How come? There, here. Open your big fat eyes. Okay. Right? Don't be a blind cow, okay? Okay, this all here we done already. So next one, of course, silver sulfate is a bit different in the sense that is 2 for this one here. Okay, expression for this one here, very simple. Again, it's 2 for your cations here. Normally it's 2 here, isn't it? So, all right, using a similar experiment data here, illustrate quantum Ag plus here, is this one here. Okay, now this for Ag plus. Okay, so if 2x is 1.6 minus 2, well, this will be half, isn't it? It's equals 2x, man. So I say it's very important to put x here. Okay, start with x here. X most dissolved, so it's 2x here, x here. Is that clear? So it's x here, so it's half here, right? So it's 1.6 here, this one here, and because it's half of this, 0.8. Okay, it's on here. So it's this one here, 2.05 to the power minus 6. You can see here. Okay, see here. Okay, so very important, right? Okay, now here again, same one. Another question about the same. Okay, silver sulfate, so it means soluble constant of this solution. Okay, constant of the separate solution is on here. It means of this fellow here. Okay, of this fellow here. For the early question, the concentration of what? Ag plus. Now it's of the whole thing, the whole salt. Okay, see the concentration of the saturation solution is on here. Okay, right? Right expression of this one, blah blah blah. Quite simple here. Now here, right? So if this x, red blue, if this x, this will be 2x. See, the x is given now, right? This is the x. So 2 times the x here, and then the x here. Earlier is half of the x there. So, okay. So again, this answer here, very simple, 6.25 to the power minus 5. All right. Okay. So we are doing quite well. So I say this one is, okay, now my here, calcium sulfate is sparingly soluble. Calcium sulfate, by the way, is used for, let's say you break your arm or leg, right? You put a plaster of Paris, this plaster of Paris. Of course, it's also your chalk. You know? Okay. Describe and explain how we see if a few cm cube of concentrated this sodium sulfate were put into saturation. That means this one here, there's no the clear solution. This is not the clear solution. Okay, right, right. So here I put wrongly. Sorry about this. This is, of course, you start with here calcium sulfate. I put, okay, this is calcium sulfate. The Ca plus. So, of course, this is your, okay, this is your solution of sodium sulfate. Okay, which will give you what? 2Ne plus SO4 2 minus. Okay, that means there's going to be an increase of SO4 to minus. So you shift it backwards, okay? Right? So you use this equation better. Write this on here. So increase in SO4, shift it forward. Because it means you see a PPT. Okay? Describe what you see. So what PPT? What PPT? What PPT? Because the concentration of this one here increase, combine effect, shift it forward. Okay? Give the equation. The equation. Okay? Precipitate or solid form, combine effect, okay, shift forward. All right. So here, and this is they play around with the numbers here. Okay, phosphate ion in water is removed by adding calcium ions in precipitate of calcium phosphate is formed. This is a solid. Okay, right, remove it. Okay, especially for KSP, remember you start with the salt and give your ions here. Okay, so remember, right? The species and the power to 3 here is, of course, power 3 here. Stoichiometry, the species and the 2 in from here, 2 here. Eyes can go wrong, no, I tell you, okay? So they ask you again for the concentration of KSP, whatever. So the solubility, this solubility here, okay? It means the maximum amount can dissolve in 1 dm cube to form the saturation at this temperature. So solubility, the word is used now here. Right? So this is X. So it's X here. This is what? 3x. This is 2x. Very simple. So then we 3 times this value here, 2 times value here, and the power 3. Okay, it's just maths here. Right? Very simple. And of course, the units is way fantastic. Okay. So don't be afraid. Minus 15, so what? Okay. is 12 minus 12, right? 20, something is wrong here. Okay, correct. Remember? Okay, this this is 26. It's plus dm cube, right? Okay, right now. Okay, so it's 6 and 6 and 6 and 9. Okay, 15. Right? So you can see it's quite simple. Okay, I'm done already. Okay, again, silver. Some we done already. Okay, this part here. Silver phosphate. This AE3, 3 here. Okay, so remember the 3 here. So it's 3 in front here. So it's X is 3X. Okay, very simple. Again, let the solubility of X. Yeah, I cannot stress, but tell you this is so important. If you don't do something, you will get lost. I tell you, this is always the solubility of the whole salt, the whole damn salt is X. Always start with this. Then you can always talk about the ratio here. Otherwise, you go wrong one. I tell you, I get wrong how many times already. Right, expression blah blah blah. Okay, very simple. Okay, again here the units here. The numerical value for KSP is this value here. Find, okay, use this to calculate the Ag plus in the saturation. Okay, and so the solubility, right? Solubility. So again, X here, 3X here, X here, again here. You want the Ag plus only, that means it's 3X, no, right? So never mind, you find X first. Okay, so here you go this one here. So remember 3X here. Okay, so here's 3 is cube. It's cube. I forgot to put a cube. See, I forget to put a cube here. Okay. Sorry, 4. Power 4. Sorry. See, I say mistake one because it's 3 plus 1, 4. Okay. So root power 4. Better not use the calculator. Okay. Put down here the maths is this one here. Okay. Very simple here. All right. You can see here 1.39 power minus 5. Okay. Right. Okay. Okay. See, root power 4. Okay. Okay. So right. We're quite near the A. Now here, the table lists values of solubility products, KSP, group 2. Remember, minus 5, minus 9, minus 10. Means the KSP decreases. Of course, if it decreases, it means that also the solubility also decreases. Smaller, but easily achieved, isn't it? So it will be PT. Okay? This is data to describe the trend of solubility. Okay, shown as KSP decreases, becomes smaller, solubility also decreases down the road. So see here. Okay, solubility will decrease because the KSP value decreases. And so the 2 points you want to mark. Okay. All right. All right. So here, write equation to show the equilibrium of solubility product. Remember, equation means that it always start with the substance. Okay. And here on the right hand side is your ions. Okay. Okay. This one mark, no, crazy, isn't it? Reference to the equation above suggests a few drops, a few cm of concentrated added to the solution also. Okay, now I again got it wrong. I went too fast. Okay, never mind. Okay, I made mistake. This slide is very stupid sometimes. Okay, this is magnesium. Okay, so magnesium. Okay, into solution here. So you put solution here. What? Of sodium carbonate. Okay, okay. So we give you, of course, 2 Na plus CO3 2 minus. Okay. So some of course will increase put here. So it will shift where? Shift backwards here. Okay. So why PPT form of as the carbonate increases, you to shift to the left. So shift left here. Because it will increase. And always come on one. See now. See? Right? Here. Why PPT form? So here, because CO3 2 minus increases, shifting to the left hand side. Or precipitating. Okay, right now here. This is the data table to cover solubility. Solubility, that means maximum amount that can dissolve to form a saturation solution. Okay, blah blah blah. Okay, because you know the KSP already right here. Okay, so use these things here, unless you're blind, idiot. Okay, right. So remember, give the equation. All right, this is the equation here. Remember the ions is on the right hand side. Right hand side. So if this is X, this is X, this is X. Okay. So this is the equation. So how do you find the solubility? Of course, I told you less solubility with X mostly. Always remember. Okay, you don't do I knock the bloody head, tell you. Okay. So X here, X squared, very simple, and then you can give your answer. But as in grams per dm cube, you find the MR. change it times the MR here. Okay, 0.27 grams, 0.27 grams. Okay, per dm cube. All right, we're very near the end. Okay, now here I've got to give some funny thing here. Okay, when this magnesium nitride suspension. Okay, now this is the equation here. They'll give you this is how you balance the equation. Okay, don't worry about it. Alkaline gas, only alkaline gas, you know, is ammonia. Don't go and think of some stupid thing. Okay, don't care about it. Okay, blah blah blah. Okay, now here calculation. Natural hydride is very soluble in water, concentration, blah blah blah. This is this same thing. Okay. Remember the equation here. The ions are on this side. This is the expression. Solubility. That's solubility by x moles per dm cube. X 2x. Okay, and put inside here. Solve the problem. Okay, very simple. It's very straightforward. I mean, you cannot go wrong. Okay. All right. Now this is a bit different. I put red, but it's the same old thing. See. Okay, unequilibrium. This one you will learn later. You learn in your chemistry. Okay, this is called complex ion formation. Okay, don't worry about this. Okay, because it's got solid here, so it's all equals here. Okay, so don't worry about this. We do that first. Okay, all right. So equilibrium one, they put KSP here because this is KSP is equals to AGB. Okay, and of course BR minus. Okay, so no need. Tak kisah ni. Okay. Okay, so forth here. Current solubility of them easy. Let's solubility X now. Okay. So remember, it is X here, is X here, is X here. Okay. So quite simple. Okay. Right. No problem with this. Okay. Right. See, okay, square root here. Okay. Now this is also we did before, okay. Silver sulphide. Okay, so solubility X. So it's 2x here again, okay, expression here. So solubility, okay, maximum amount, see the word is used, okay. Remember, all right, remember I told you, see, they didn't ask you yet, no, they will ask you, define solubility. So I put down here, you don't, remember you knock your bloody head. Why you just start? Okay, see, solubility, first thing I do, right, solubility also is a maximum amount. Maximum amount. Okay, maximum amount in grams or they can dissolve in 1 dm cube. A given temperature to form what? Solution. Okay, this is meant by solubility. Okay, so make sure you go back to your original things. Okay, so solubility is equal to this. Okay, this X equals to this. Okay, so find KSP very simple, right? So here is remember, this X is 2x now. So 2 times this value here. 2 times. Okay. This is only 1 time here, so 2 times here, and the square here as well. So it's 2 things, okay? All right. So here, okay. Calculate a minimum volume needed to dissolve 1.00 grams of silver sulphide under natural condition. Okay. So of course, because all the time the concentration is in what moles per dm cube, is it? So the first thing to do is to change it to find MR. Okay, 1 gram. This is your number of moles. Okay, right? Okay, minimum amount of volume to dissolve. Okay, that means to form a what? A saturated solution. Okay, right? Remember the KSP is this one here, and this is your concentration on. Okay, this will form this is the concentration of the saturated solution. This is solubility, okay? So right, this is one here, 1.16, 1.16 here. I know, this one here. This form a saturated solution. So it goes to the number of moles, which is this one here. What's the volume we need? Okay, so it's just mathematics. So it's very high, 3.5 to the power of 14. How many dm cube you need? Wow. Okay. See? 14. Right? Okay, we have finished half an hour. So we have finished. By the way, we have finished all the physical chemistry. Only one last part here, if you want to see. Okay, one last part here, which is your this one here, partition coefficient. This one actually comes from the what is this experimental techniques. Okay, which is like your mass spectrometer, all these things. Okay, so because it involves an equilibrium, so I include it inside here. Okay, so this one will take 1 or 2 times and we finish it. Then we finish all our physical chemistry already. Physical chemistry, and your organic chemistry and all your analytical chemistry will finish. Only behind is your inorganic chemistry. So we are done very well. I don't know how you guys are doing at home, the MCO, and how you guys are going through my notes and going through these videos and learning it. Because when you come to school, I will go quite fast. Okay, you don't catch up, you can start digging your grave. Okay, if you want to do that, I don't care. I mean, I've done my job. You are lazy, you will reap what you sow. The Bible says very true. A man reaps what he sows. Right? You sow to the laziness, you fail. You sow to in all good habit of disciplining yourself to study 3 or 4 hours a day, you will surely get A or A star. I don't want to say any C or D's or cows or donkeys, idiots, okay? A star and B, the most, the least is B. Some of you get, of course, you get B when you laugh like hell already, okay? So please do your work, okay? Don't live a life for what you call meaninglessness. Jordan Peterson say, you know what's meaninglessness? Is to what is I forgot the term is random pleasures. You just simply do. What you feel like doing, you do. Okay. You don't plan for your work. Plan. Failing to plan is planning to fail, my dear ladies and gentlemen. Okay. Enough of preaching. Okay. So I hope you're doing well. Okay. And please study hard. So I will end here. How to end this crazy? Okay. Stop.